Venn diagrams come up in a couple of different ways. We've used them in the past when we were doing highest common factor and lowest common multiple. So if I refresh our memory, and we'll do some examples on that, how do I find the highest common factor and lowest common multiple of 15 and 18? Well, if we do a little factor trees, we find that 15 is 3 times 5 and 18 is 2 times 3 times 3. They share a pair of 3's. I've shaded that in orange. I'll put that one in the middle. Only once. So on the left, 15 is 5 times 3, 18 is 2 times 3, and that 1 3 is shared. The highest common factor is the bit in the middle, the join, the intersection, and that is 3. The lowest common multiple is what's inside all of the circles and the intersection. 5 times 3 times 2 times 3, which is 90. We also come across a problem where if they give us a set of numbers, that's that funny looking curly E, which stands for set, so we're only interested in the numbers 1 to 16. It says, if I put all the multiples of 3 in circle A and all the multiples of 5 in circle B, can I complete the Venn diagram? Well, you can see that 3, 6, 9 and 12 and 15 go into A, 5, 10 and 15 go into B, 15 goes in the middle, but don't forget all the other numbers are outside the circle, they need to be there as well. What we've now might be asked to do is find the intersection. That's the funny looking red N. What's the probability of the intersection? Well, if I choose a number that's in the intersection, the only number that's in the intersection is 15, so that's 1 out of 16. What's the probability of the union between A and B? So that means every number that's inside A and B and the intersection. There are 7 numbers out of 16 in total, so the probability of A union B is 7 out of 16. What's the probability of P dash A? The dash stands for not, which means how many numbers are not inside A. Well, 3, 6, 9, 12 and 15 are inside A, which means 11 numbers are outside it. So the probability of P dash A is 11 out of 16.